got my coffee, so I'm here. Good morning. So we're going to do today. We're going to talk about distribution, and so this is a form of repetition, but it's a pattern that has to do with something spatial. So it could be a line or it could be a surface, and this is once again like a really powerful idea in architecture. So we're going to talk about how to break things down into component parts in Grasshopper, and then how to use those parts to like build other things. And then, so this is going to start to get architectural pretty quickly. So we go ahead and throw some slides out really quick, and then we're going to do a couple little demos. And basically, the assignment, we're going to give you a volume and have you do some kind of a distribution pattern like over that volume. And once again, you can kind of duplicate patterns you can see here. You can look for architectural precedents and try to duplicate them. As we kind of go on, we're going to kind of give you more and more freedom, like for some of these things. But once again, these are kinds of things you could probably use right away when you're doing some designs. Yeah, so just real quick, I'll show you what I'm talking about. Get my slides up here. I'm actually on the wrong. There we go. So this is just a simple like bridge. And this is one of these Calatrava, things that if it's white and curvy, you have like a 90% chance of it being a Santiago Calatrava project. He's a Spanish architect. You've probably seen some of his work. He actually does a lot of stuff in the States. One of the rare architects, that really does a lot of architects practice in Europe and China, but he also does a lot in the United States. You might remember if you've been to Milwaukee, the really big museum that has the things that open up. That's the World War I museum, I think. Anyway, but that's a Calatrava. And the new station at World Trade Center that has like the Oculus, that really big light. That's also Calatrava. Although after that thing, they might not let him build in the United States again. I think it was like hundreds of millions of dollars over budget. Yeah. So anyway, this is a Calatrava, and actually, so this is just kind of going to be the first thing I'm going to use to sort of demonstrate some basic principles. And you can see like on this bridge here, there's all this repetition once again, right? But it's like there's several pieces like talking to each other. So you have these kind of main kind of ribs, and then across the ribs, there are these joints, and then between the ribs and the deck, there are these cables. Calatrava loves cables, loves suspension, tension, and then these railings, right? And these are all the different kinds of things I'm talking about. So like how to get that geometry, and then how to like break it down into pieces to create structure, to create order. And this is something we do in architecture a lot, especially nowadays if you have a form that's really like dynamic or whatever, you still have to build it. You don't just have like a magic machine that just like, extrudes it or rolls it or prints it or whatever. You usually have to break it down into panels, and those panels have to be like manufactured, right? Or more often, these days, like up until recently, most architecture is already some kind of known quantity where you've got a 4x8 sheet of some material, or you've got like a brick, and things are made out of those smaller like units. And so like trying to break something down so you know how many units you have is a really, really common activity, right? Because it's cheap that way. If you can make something that's mostly made out of standard sized like units, that becomes a pretty cheap project. If every single piece is unique, you can get really cool stuff, but then every single piece is expensive. Okay. Anyway, so I hope that makes sense. So we're gonna go. I'm gonna start to talk about this in terms of Grasshopper. So let me get you up in Grasshopperville. All right. Hello. Okay. Let me turn off my video controls here. Let's see here. Media controls. Okay. So in order to begin to like look at these kinds of things, the first thing we're going to look at are like curves. And I think we've done like a little bit with curves before, but I'm going to talk about them like from like a parametric kind of standpoint. So we're going to actually go on Rhino for a minute, like believe it or not. So go to top view. And you don't have to follow on with this. I'm just kind of talk through it, but I might ask you some questions also, so look alive. Okay. So the first, before we talk about curves, we talk about lines. And the most basic, thing we've done is work with line, going all the way back to AutoCAD. And a line just is simply defined, I go off the grid, literally, dad jokes. It's just 2 points, right? And you can construct a line by taking 2 points. That's a straight line between 2 points, okay? A line that's defined by more than 2 points is called a polyline. Makes sense. And again, we're still in line like territory. So these are 3 points now, and you've got 2 segments, and that's a line. Okay. Now, where this gets like a little bit different is when you get into curves. And what's interesting about Rhino, what we like about Rhino, is that a lot of it's handled by this kind of mathematics called NURBS. It's non-uniform rational B-splines, and you never have to know what that is. They gave me a test on that when I was a student here, and I was really upset about that. And I went to MIT. I never had to use that. Like, it never came up. It's meaningless to you. Here's what it means, though, in terms of a NURBS curve. I rarely drop the grad school, but I'm going to put that out here, okay? It doesn't matter. So NURBS curve, and they call this a control point curve. See, even they don't even care that it's NURBS. A control point curve. And the control point curve looks like this. So you see how they're a little bit different. I'm going to snap to points here. So if I draw a control point curve along that, you can see that actually is like quite different. Okay. First of all, it's a curve. It's nice. Like, it's, nice. We like curves. And second of all, it passes through the start point and the end point, but it doesn't pass through the middle point. And that's because it's a different kind of object. To show what that looks like, we're going to go ahead and you got this little control here that says show object control points. So I click that, and now you can see where that point is. And you can see that if we move, so when that point is in line with it, you get a line. And the further out you like move it, you can actually like, that controls that curve. But you can see if I want to get a curve that does touch that point, look how far out I have to go to get that point. Okay. So what's it doing? It's using this angle, right, to inscribe or to like calculate or process this spline, this B-spline. Okay. And likewise, it's important. Well, because A, it doesn't behave the way that you'd expect something to, like, normally, and B, it's a branch of mathematics that gives you like extremely precise curves, no matter like how far away or how like zoomed in you get. It's a really precise way of describing curvature. And it's the math that we used to make like sailboats and ships and Frank Gehry buildings and Zaha Hadid. It's always hard for me to get that out. Zaha Hadid buildings, right? All that like cool like curvy stuff, and Nike shoes and like iPhones and everything. Those are all described by NURBS. Okay, and so that's why that stuff's important. And it's important to understand like what that mathematics is. So again, if I zoom all the way, no matter what it's going to be, it's not going to break down into any kind of facets or any sort of thing. And that's like when I tried to describe to you earlier in the class, when I made a sphere, right? And we look at it. Surfaces in Rhino are made out of are NURBS surfaces. But it's taking this mathematics and applying it to like a surface form. Okay. And so again, that's why they're perfect. Like no matter how far zoomed in, if I were to cut a slice of this, or like a trim, it's perfectly described, curvature. And in fact, I can turn on the control points, right? As we've kind of noticed now, I can just do some distortions, it doesn't distort perfectly. We'll get into why that is in some time, but that's why you can do that. And you can't do that like with a mesh, right? It's because of the way that they're described, because of the control surfaces that they have. And all this is to say is that like from a like topological standpoint, when we talk about things that are topological, we just need the parts. Yeah, another big word. Just means that there's points and you get a line, or there's a curve and it's made up of control points. NURBS curves are interesting though because you can also subdivide them, and that's something that you can do with a polyline, I guess, too, but it's more fun with a NURBS curve. So you can do a command called rebuild, and when you rebuild something, you can add as many points to this as you want to increase the level of detail. And then there's the curve degree, which is the number of points that are involved in generating, one of the curves. And the default is usually 3, which means you've got 2 endpoints and a midpoint, and that's what describes the curve. So if I do this, now I've got a 5-point curve with a second degree, and that means I can go in and I can move these control points around, and then I start to get like our really cool like architectural stuff. But you can see like where these things get like really out of joint, right? These out in space. And there's another kind of curve, and I'll end with this, that we use a lot because it works more like what you think it's going to, and it's called an interpolated curve, and it's the second one on the list. And an interpolated curve is a NURBS curve, but it's forced into, it will go to each point in space. Okay, and so I go click, 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 and so now, and then I have to end it. And so now that thing will go, but look, it actually does, it automatically generates that like control point that I showed you, that's way out in space, right? So that is the interpolated curve. Just for giggles or whatever, I'm gonna make an interpolated curve. I guess I can't snap to those. Oh wait, yeah, not. Maybe I can't do that. I can't snap to CVs. Someone's gonna tell me that I can, but I don't know if I can. Anyway, so like if you want something, and here's the thing too, like an interpolated curve, again, it's gonna work a lot more like a rubber band or like something that's like run around something. So if you want something that's like very specific for a curve, an interpolated curve is usually like a smarter or like easier way to go. I think it's smarter, but it works more intuitively, which is always useful. Okay. All right. So endeth the lesson. So that's important because we're going to start getting into some of these things. So if we go back to, I lost my things here. There we go. So if we go back to Calatrava just for a minute. So what we could do with Calatrava's thing, there we go. Certainly we can describe these things as curves, right? And we can even, take a curve and using like moving points or using a move tool, we can describe like multiple curves like parametrically. Okay, and that's what we're going to do. Okay, so sit tight. So this is where we get into architecture like right away. So to make a NURBS curve, turn off my handle. There we go. Okay, you go into curves. Yay. And we're looking at, there's also all of the primitives, and there's it's lots of curves. So line is there. We've got let's see, and then we get, so there's line, and then spline is over, and actually forgot SDL line, our original friend. And then so we've got the interpolate curve and NURBS curve and polyline. Okay. And you can see as all these are the different kinds, and they all have their uses, and we'll talk about a couple of them today. But anyway, so yeah, so you can easiest way to do this, let's see here. So I'm just gonna go ahead and start. Let's just start with a like a point. So we construct point. Why not? And then what we can do is we can either do the move command, or we can just do a number slider. And I'm just gonna do a number slider because it's easier to work with. So let's call it 20, 0. And so that's 1 point. And then I'm gonna go ahead and just take another point and just move that in the X. And so now I've got 2 points, right? And you can make a line with those, right? Just a regular line. by connecting, you know, the first point, so A and B. That's it. I'm gonna go ahead and turn off my grids so you can see what I'm doing. There you go. Now it's clear. Okay. Turn off my media controls here. Still with me? Okay. So then like a NURBS curve, right? We can draw it kind of like I did before, but to do that, so we're gonna do something else with the line, with sort of like the line like topology. We need to find the midpoint of the line. And I could be wrong because they keep changing stuff on me, but there isn't just like a midpoint component, which is dumb. I'm going to say that. But what there is a component that you can use that's called point on curve. And point on curve just has a slider and you plug something into it. And by default, it is the midpoint. And so 0.5, you know, but you can do quarter point, you know, third of a point, midpoint. And that's easy. There are lots of different ways to do this. Like, again, don't write me letters or send me emails or whatever and say, yeah, but Nick, whatever. Yes, I know. There's like a million different, but this is like easy. To that point, we're going to go ahead and make another container, and then we can, and actually I'm going to do it this way. Sometimes it's useful spatially, like so this is the start point, end point, and middle point. And so when well, anyway, I guess I'll do it this way. And I'm going to go ahead and take this point and move it up into Z. No, this one I have to move. What am I talking about? Move Z. And I'll go ahead and grab this friend over here. And so now I'm going to take that midpoint and move it. And where to go? It's really high up there, I think. Whoa, wait a minute. Oh, I'm not in the, I'm in the Y. I'm in top view. Oh, well, actually, okay, let's go to front view. Aha, looks exactly the same. And then I'll put that, yeah, there it is. Okay, I was in the wrong view. I pay attention to that. And now we got a friendly little point up here. And then we're going to make a NURBS curve. Okay, now if you stepped away, or I don't know what you would be playing right now on your phone. I don't know, not Pokemon Go or whatever. If you're distracted, you're going to miss this. So pay attention. Okay, you're going to plug these things in order, and you're going to hold shift because the NURBS wants points. And we don't have a list of points. We have 3 components that have points. All right. So we're going to say start point. And we're going to plug this one in. And then we're going to go middle point. It doesn't like this. We're going to go middle point. We're going to hold shift. See the little tiny, teeny, tiny X next to my cursor? Whoops. It did too many times. Now it thinks I need help. Okay. You're going to click on the shift and you're going to plug it in for V. Oh, something's starting to happen. And then you're going to go to the last point and then you're going to hold shift and plug it in. And now we have a curve. It's parametric. Ooh. All right. Funzo. Okay. So we've got that. And in fact, and it's angry at us. Why is it angry at us? The degree must be less than the number of control points. That's true. This is right now it says it's a 3-degree curve. If we want to make it not angry, just make it a 2-degree curve. It's fine. Doesn't matter for you. And don't make it periodic because that'll make it a circle. You don't need that. It's kind of cool, but you don't need that. Don't do that. So now we have like a bow. We can shoot architecture arrows at our enemies. I don't know. We can take this even a step further. And if we take these 2 points that we've got and we move them, we can take this one and we can move it in the Y. And we can make a slider. Let's see. This one I'm like, negative 20.0 to 0. 0, 20. And I'm moving in the negative Y. So take this one. Yeah. And so now I've got this point like this. Okay. And I'm gonna do the same thing with the other point. So you do that. if I plug these in instead, so if I start plugging things in, it'll basically stop this like command. So I can plug this in. Yeah, it hates me again. Okay, plug it in. Plug it in. And so now we actually have. Oh no, that's interesting. That doesn't do as much. Okay, well anyway, so that gets us like a slight like an even more of a bow to it. It's like it's skating or something. And if I really wanted to, I could probably pull this point in. But anyway, so you can move these in 3 dimensions. So you get different kinds of effects. Okay. And I'll show you something too. Something we do a lot in CCL because we have to share code and stuff like that. This starts to get really confusing, right? And again, my discipline is terrible in terms of getting these things together. You can, if you want to align things, you can just like select them and then you kind of click off to the side. You can also click on things, and I'm doing shift click, and you can center them. Okay, and all that's great. But like the other thing that we find useful is if you do, if you have an object and you do Control G, that puts it into a group, and then you can give it a name. And so you can say like first point, and you can call this one last point, and that gives you a little bit of a reminder. You call this like middle point. Actually, I should have called that one start point and middle and end point. Anyway, middle point. So that gives me, you know. And then somebody the other day we were looking at this. You know, you can do a mirror component. So you've got the curve, and that's the geometry, and the mirror component wants a mirror plane. And in this case, it's actually mirroring about this axis. So again, if we're looking for this, we want to really mirror it about the ZX axis. Or the XZ, I always get that messed up. Let's see if that works. Yeah. There you go. And so now again, it's fully parametric. You can move these too far apart. They're gonna just do a do-si-do. But so now you've got these things. Okay. Okay, let's turn off some stuff. Now take a pause here. At this point, I don't know, you might be like, how am I ever going to do that? Well, that's what I want to kind of talk about today, is to say, like, I want you to start to see like what the parts are and what they're called. I also want you to start to look at architecture in a way where you can start to deconstruct it as geometric like operations. It's easy enough for you right now to like draw something, right? Like if I had you make a sketch of something, or if I showed you a picture of something, you know how to draw it, like you know how to break it down with your eye. But I want you to start to think about these parts and start to think about things that you see, and think about how you would actually break things down like in the world. And also what I'm trying to doing with these kinds of things, and what you'll see more online, are these patterns. And like a lot of these things like show up like really, really often. And especially when there's something that's really stands out, I will stop and point it out to you, and I'll say, this thing shows up a lot. Okay. And so don't be discouraged by that or anything. Like that's just natural. Okay. But we're only, you know, we're not very far into this at this point. So don't worry about it. And you know, and we're here to help. So anyway, so all this, turn this off here. Okay, so I've got points kind of everywhere. Okay, now we're going to start to bring this home. We're going to kind of tie this together here. Okay, so I got these two kind of parametric curves. They're like based on one another. I want to make these railings like in the Calatrava, or I want to make these cable connections or whatever. And so like I've got these curves. So now I'm doing this thing where I actually want to pull that curve apart. Okay, I could certainly go. Now remember, these are, you know, I've got these points here, right? And I can use them, you know, certainly. But let me show you something else just in case, because these things are way back here, right? And I want to show you something. So a really easy way to get points. So we try to get a midpoint from something. What if you have a curve that you got out of something, but you want to get the start and end points? There's actually something called endpoints. And so I can take these curves, and that'll actually give me the start point and the end point. And in fact, I need it for the mirror one because the mirror, I didn't make the mirror one out of points. I made the mirror one out of this one. So I need this one anyway. I knew I had a lesson, right? And so now, you know, when you've got these points, that's the start point, end point, start point, end point. Then you can start to build some stuff with it. So I can get my line tool, like I can do my line AB, and I can go in, and if I take these two, I can get the connecting line back from those two things. Remember, I moved these. I don't have the line that exists between them, right? And samesies here. I've got these, right? And if I wanted to make, so, and that gets me to another thing. So I talked about how you can make surfaces out of NURBS curves, and they are NURBS surfaces. Well, that's how we loft stuff, right? So loft is like a really important thing. So you can take the curves and make them into a surface. So if I plug in these two things, and remember, for these, there's another one where I got to hold shift. Don't email me and be like, why doesn't my loft work? Hold shift, plug it in. Now you got a surface, right? You could do that with these. You can do that with any list of curves. And you can do it with a lot of different things, okay? But that gets me that like automatically. And again, to kind of prove the point or whatever, this whole thing's parametric, you know? Like you can get, it's all those variables are like built in. Okay, so that's that surface. Next, we're going to put those cables in. So to do that, we're going to divide these things. And this is really powerful. So the command we're going to use is divide curve. And you can do this in different ways. I'll show this. So divide curve takes the curve and takes a number of segments, and split segments, we're not going to do that. So we're going to go ahead and let's see, I probably should label these two. So the curve in question is we're going to start off with this one. And we're going to make a copy of it. And we can take this curve, right? And so what we can do, what that gives us is points, list of points. Right? Just to prove a point, just 10 points. Let's go ahead and do a number slider too. Number slider, let's call it 20 point. I'm using a lot of those today. Okay. And these are dependent. I do not want these to have different lists, so they should be dependent. And then the last thing we're going to do is add a line. A, B, boom. Now a couple of things, you know, are kind of happening here. Like, I mean, so you obviously get the cables. What we're getting is kind of a rainbow though. Because what? Because the length of this curve is actually different from the length of that curve. As you guys know, right? Like if you have something that is the shortest distance between 2 points is a straight line, curved line is longer. So we can divide the curves, but we actually end up getting kind of a wonky bridge. So I don't know, not super jazzed about that. So instead we can do something else. We can do divide length. And so what we do with that, I'm going to delete these. And so what we can do with that is take this curve, plug it in here, take this mirror and plug it, take this line, plug it in here, and let's plug in length for both of these. Now it's different because it's not dividing it by number, it's dividing it by the length. I don't know if I like that either. That doesn't seem as good. Shorter length is going to be more lines. Let's see if this is better. Whoa, uh-oh. Oh, aha, that's because the lengths are different. Sorry, yeah, so if you divide it by the same length, you're going to get different effects. Oh, uh-oh. Okay. Let's see here, evaluate length. Well, anyway, so there's different, let me make sure I got this right. Yeah, I might need to do that anyway. Okay, well anyway, so all this is to say there's different ways of dividing these curves. I'm gonna stick with this for now. Let's see, and it might get, Yeah. Nope. Okay. Anyway, well, we'll do this for now. I guess what you would do is project the lines down and then intersect them. I'm not going to do that. Just take my word for it. So this is just a way of dividing. So like divide curve is like super key. You can do all kinds of stuff with it. It shows up a lot. And if you, one kind of thing I use a lot as a pattern is like, if you divide something and divide something else, you can get them to talk to each other. So let's just pretend like I did this right. But the other thing that is kind of an interesting way to do this is to take these, the same kind of structure, probably a better way to do it, and take the curve, the same curve, basically mirrored, and then you can get that. And these are all parametric. So that's actually kind of a nice pattern. And just to cut, I mean, this is kind of what we did. What I did when I was working like with Donovan with like the cables was that there was a thing, and then we moved it up one, and then the two things like talk to each other, and that's how we got the suspension cables. So that's that idea. Okay, so anyway, I think you can figure out how the other side works, but the whole idea of this is that you have a line that's made out of points, right? And you can move those points and you generate a line. You can take those lines, you can make a surface. You can take those curves and break them back down into points again and rebuild new curves with them, or new surfaces with them, or like what have you. These things move back and forth depending on the information you have, depending on like the constraints that you want to put into the system. Breaking things down and putting them back together again is like one of these really, really key ideas. Okay, so just going all the way back through the script again, starting with points and moving them, we know how to do that, right? To construct lines, and the most simple line is 2 points. We found the midpoint of the line, and we can move it up and down. And in fact, actually, if we want to get crazy with it, we can actually move the midpoint too. It's like doing a pop and lock or something. So that's, and again, to make this fully parameterized, and you get a lot of variation out of that. Okay, and then to make a NURBS curve, remember we hold shift and we add them all together. Second degree, if it's 3 points, we showed the mirror command, and then we got the start and end points, made some new lines. We lofted it, so take the two curves and loft them together. And then lastly, dividing the curve and making some new lines. Now, how would you get this into a form? You can use the pipe command, and pipe has a radius and it takes a curve. Be careful about how much you use the pipe command, because especially if you have a lot of curves and stuff like that, it can really create a lot of geometry and it can mess up your day. So just be very, very cautious of that. I'm going to go ahead and I can, so if I pipe, you can see there that actually makes the geometry. So those lines are just lines until they get turned into something, right? So if I start plugging things into pipe, then I get something that looks more like, and I just plugged them all in. I probably should make the other ones thicker, but I think you guys get the point. So these are going to be super thick probably. Oh yeah, I copied it. That's why. Anyway, so yeah, you can make a hierarchy to it. Yeah. So anyway, there's all these different parts to these things, and if you're really smart, you can make a really, really complex system of these things. And I made this really quickly, but let's go back to the slides. Actually, before I do that, does anybody have any questions about like this stuff or like what I just did? Again, just to kind of show you how these things are broken down and what we're talking about today. So points, curves, points on curves, surfaces. We'll get there.
I have a question.
Go for it.
Else gets yeah. So you were adding the endpoints when you had just the two curves, and you were adding the endpoints to one.
Yeah.
And you said, "Oh, I generated this other curve by like I don't know mirroring or something."
Yeah.
So you can add endpoints to it, and then you did add endpoints.
Yeah.
when you added those extra endpoints, did that generate another curve from that, or was it
Oh
just
no,
okay.
it's just asking the curve, hey, what are your points? Yeah.
Okay.
Yeah,
I'm never quite sure what's real or not to the Grasshopper
yeah.
times. So like,
I mean, none of it's real, man. But it's I think in memory, as I said, like, you know, when you have a copy of something, it's free. It probably does create an instance of it in memory, but it doesn't exist. Like, it just needs the points. Yeah. It's philosophical. It's Schrodinger's curve. I don't know. It exists and it doesn't exist. But yeah, that's the main thing. So you know, these things just get they can get kind of fun. But anyway, that's just a demonstration of a couple of different things. Okay, so let's go ahead and look at surfaces really quick. Actually, let's go back to the slides, and then we'll sort of take a look back. Let's see here. I go new share, go back to the slides. So if you go back to this again, you know, you can see how, like, if you pull those points closer together here and pull them apart here, you can get more of like a sort of like an Under Armour, you know, kind of like swoosh, you know, kind of thing, right? And you know, these two things are kind of lofted together. It's kind of an inside and an outside curve. It wouldn't be that difficult to double these things up, right? So you can start to like think about these kinds of things. I'm not going to say you're Calatrava now, but there's a logic here that's easy to see, right? And so let's take a look at some of these other things. So and all these kinds of things. So like let's go back. So this divide curve thing is really, really important. I don't want to go too far like away from it, but if you could take something like along a curve and divide and express some kind of like geometry, you've got a lot of like flexibility for things. Like you can start to see like where shingles or bricks or like louvers or different kinds of things can like flow around an object. Okay, you could even do like, you know, if you have like a street, you know, street lights, right? And lots of things that are distributed, you know, railings. We talked about like, you know, these kinds of things, you know, distributing things as like railings. Okay. Yeah, so let's take a look at that really quick, if y'all don't mind. I don't think you have a choice. I mean, I guess you do, but all right, so let's go ahead. We'll start a new script. Okay, so real quick, because I don't have a ton of time, but so let's I'm drawing a curve in perspective. Whoa, I shouldn't do that. Don't draw in perspective. Bad. Good enough. Okay. So I like drew a curve. And in fact, I would say in most of these instances, when you are doing stuff, a lot of times you're going to extract a curve from something that it's in your project, or you're making the curve because that's how you're starting the project, right? It's your geometry. Okay, so how do we get geometry into Grasshopper? We can use one of the like components with these like black kind of things that are under parameters. And we're going to reference this curve. So just set a curve. Boom. And then I can hide it. So let's go back to this divide curve thing. And we'll go and we'll do just a 20. I like that. So remember, like so this gives us points, and it's evenly, these are more or less like divided along that curve. Remember, once we have points, we can distribute things. Right? This goes back to the last thing we had. So like if I was to do, let's say our old friend, the cylinder, I can take those points and I can put, and these are teeny tiny, I guess. I never have a sense of scale on these things. Yeah, good enough. Okay. And we'll call this, yeah, those are not the right size. Let's call it safe. And yeah, so we have cylinders. And remember, the more inputs we have, the more outputs we have. And so you can say like right away, like that's actually kind of an interesting way to get to sort of get these patterns. And you can imagine like really quickly how something like that, not doing a super great job of it, but how that could become a railing. You could take that initial curve and move it some distance. Oops, I needed a Z. My bad. And then I can make the railing length the same thing as the distance. Or the things. And now I've got, and I can take those two curves I made and I can pipe them. And I can even pipe them by the radius if I wanted them all to be the same. And why not? Because we're parametric people. So like, and you gotta be careful with the pipe thing because it doesn't always terminate well. But anyway, so what I mean is, oh, somebody announced that. Oh, hey Timothy. Okay, so start with a curve, divide it. You can put some geometry on it, and these could be lines that we pipe too. Yeah, I just made a cylinder, but so now we've got a railing. Whoa, don't do that. Anyway, but you can see how these things can kind of stack up like pretty like quickly. We could do another cross section or another radius or something for the railing. We could do all kinds of patterns and stuff for the railing. But that's just the kind of simple kind of thing. So to go all the way back to it, when you divide something up, you get points, and points are one way to distribute things, right? So the other thing we could do is we could use like orient or something. But I want to show you like a couple of different things like for this. So if I made a rectangle and I placed it on these things, I need to do my domain construct domain. Yeah, it's regular domain. Hang on a second here. So I'm gonna do this. Okay, it's gonna take me a second to build a thing here. So I'm gonna build some rectangles. Circles are great because they're easy, but they don't have a direction, and I want to show you something in a direction. Believe it or not. So let's see, -A. And this is a pattern. Remember I told you, that would acknowledge patterns. This is a pattern. This like rectangle building pattern. Okay, so what do we got here? Yeah, okay. So let's say I was trying to do like a brick wall or something, and I put all these things on here. Yeah, let's just go ahead and extrude them too. So I'm going to extrude these in the Z by some amount. Good enough for now. Cap. All right. What's the problem with this? Well, they all come in the way that the base geometry is lined up. Like they're all generated with that, XY, like a pure XY. Okay. They don't flow along the wall. Okay. And that is probably a problem, right? So how do we get them to like obey the like curve? How do we get them to like drive on the road, right? So this actually, so you wouldn't use the divide curve. So the divide curve has the points. The points are actually used as planes, but we want planes to actually be like rotated, okay? And so what you would actually do is, there's one that's called horizontal frames, okay? And if we plug that in, get rid of, I thought I turned all these off. All right. All right. And I realize the scale of this is crazy. So I'm going to show you the difference here. So this is, you can see if we just have planes made out of the points, you can see how they're all straight. They're all aligned with each other. I'm sorry, these are so small here. Okay. You can see these. The difference is that if you do the frames, you can see you can see how that x-axis is actually aligned with it. That's all the difference in the world. Okay. That's what that's going to do. So if I plug that in for my frames, you can see how they actually move with it. Okay, and that's much nicer. And now I know that my bricks kind of suck because they need to go horizontal and not vertical. So take that, Sensky. Okay, fun. So I want to, yeah. So this is not going to be the best way to do this, but I want to show you another kind of pattern that's going to come up later. Okay, so just bear with me. So I got all these bricks. How would I make like a brick wall with these, right? Like that might be a question that you have. We've seen some stuff like that before. I'm gonna show you something really easy. So you can take all those bricks that you've got, and I'm gonna go ahead and just do a geometry component. I want to move them all by some amount, and I want to move them by row. So I'm actually going to graph them. I know. Wait, that's not what I want to do. Oof. Maybe I guess I'm going to group them. Just do that. Okay, so now they're one group, and I'm going to go ahead and move them in the Z, and I'll move them in the Z by the distance I extruded them in the first place, right? But what I'm going to do is actually move them in a series. So let's say we're going to take this, and the first number is, because I already made some. Okay, first number, and the step size is going to be this, and then let's see. Yep. Okay, good enough. And of course you can say, Nick, that's not a brick wall. It doesn't look like, doesn't have the like stepping pattern, et cetera, et cetera. Okay, so how do we do that? So what I'm going to do is this. I'm going to go ahead and hide these for now, and I'm going to make a branch of this thing. And so what I can do is, this is kind of a hack, but let's see here. It's not the way that I would always do it, but I'm going to take this branch here, and instead of this count, hey, Alan, you okay? You're on mic. I don't know. Okay, anyway. So I'm just gonna add a brick. So like I could go 21 or 22 or whatever. Okay. And so what that's gonna do is that's gonna give me a different, so I've got like a little bit of an offset. Okay. You guys can kind of see that, how this is gonna offset there. And I can play with that if that's not right. So then I'm gonna take that though, and I'm gonna make a complete copy of the wall. So I've got two walls. And actually now this makes me think that I want to do, I'm just kind of going to goof on this, but it's not the way you really do it, but I'm doing this very, very fast. So again, yeah. Okay, so I've got two copies of the wall, and you can see these groups here. Okay, so I'm going to do this. Okay, so when you're doing, so there's these patterns that are in Grasshopper that lets you turn things off and on, and they're called culling. Which we're from an agricultural background, so culling is something pretty familiar to us. So culling is like when you're harvesting cattle, you're like killing something, right? You're gonna cull some chickens or cull some beef or whatever. And so culling is like take these things out. So you make a bunch of stuff and then you can remove some. Okay. And what I'm doing to do is it's called a cull pattern. And there's lots of different things you can do with this, but we're gonna do cull pattern. And so what this is, you put something in and then you put in a pattern, and the pattern is like true or false. If it's true, you keep it. And if it's false, you get rid of it. Okay. And so check this out. I'm going to take these, plug them in, and I'm going to go into the pattern. You can say edit, manage booleans, whatever. And I'm going to make the first one, I'm going to delete. So it's true. And then the second one is going to be false. Let's see if I got that. And is it not gonna? Oh shoot! It's not gonna let me do it on groups. Maybe it won't let me do it on groups. Uh-oh. Okay. I think I got myself stuck into a corner here. Let's see what I get if I do this. Oh shoot. Okay. Grouping might not have been the way to go here. Let's see here. Okay. Well, what I wanted to do is turn one row off and the next row on. But I think I got myself in trouble by using groups. Let's see here. Let's make this all. Let's make these all one thing. Well, let's see what happens if I do this. Maybe I didn't need a group after all. I think I could probably get away with yeah, if I graph these. Yeah, we'll do that. Okay, my bad. Don't use groups. Okay. What I did was, okay, so I plugged it in. Groups will work, but we're gonna just graft. Yeah, there we go. Okay. Okay. Oh, and then it's not doing what I want it to do. Shoot. Okay. Cull should remove every other one, unless I got this wrong. Ugh. Oh, because it's true. Jeez. Oh, pay attention, folks. You have to make sure that you hit enter. Oh, I didn't do it. There we go. Okay, true, false. Okay. There we go. Now I probably should have done groups. Okay. Okay, let me take a step back here. Because I didn't press enter, I thought that I broke it. Okay. We'll fix it later. There we go. Okay. Okay. So what happened was that when I set my booleans, I set it both to true, and so everything was kept, so I didn't see what was happening. So I didn't need to graph it after all. Okay. What happens when you do things live? Okay. Now I'm going to do the opposite pattern here. So if I plug this in, I am going to go and I'm going to flip these so it's false true. And there you go. Okay. Yuck. What was it doing? Yeah. Okay. So this is how you can get kind of a brick pattern or thing. So what do? We took a curve. We use the horizontal frames to flow along a frame. Placed a rectangle on it, extruded it. Okay. If you wanted to zip two things together like this to do kind of on-off kinds of things, right? You make two copies. This is actually where Ben's thing comes into play. You know, do things exist or like whatever. You make two complete copies of it, and then you're going to turn off like half of one and half of the other to get your final like thing. Yowza. Okay. And you know, once again, these are parametric. So if I wanted to change the spacing of these things, you know, change the thickness of them or whatever, I can certainly do that. You know, these two lists of things, and I can change the like brick height. I can change the number of like blocks. That's that one. Ooh, I can get patterns. Uh-oh. They accidentally architectured. Cool. Neat. Although structurally unsound, right? That's not how bricks work. Maybe if you have a lot of steel in them. Oh, they're too thin. Oh, look at that. I just fixed it. Architecture. Okay. So like once you get these kinds of things, again, you can start to play with them and get some things. Okay. Like just real quick here. I'll show you something else that comes into play. Actually, before I do that, so we like broke it down, made our groups, yeah, and then cull. Okay. So there's different types of cull things. Okay. Let me show you something else since we're talking about this. So here's, whoa, what did I do here? Oh, because the spacing is like crazy. That's why. Oh yeah. You can also do something cool too. You call it a random reduce. And so you take a list and you give it the number of items you want to take out. And I know you folks love randomness. So you can plug this in. Let's see. What? Oh, it's a group. Oh shoot. Okay. Let's flatten it. Does that work? Nope. Okay. You got to plug in all the stuff. Sorry. Okay. Yeah, this is where you don't want to group. Let's see here. Shoot. Okay, so I'm gonna geometry. Okay, yeah, this is a good data lesson too. So we got our groups, and we're gonna plug them in here, and we're going to graph them, and then I'm going to flatten them. So I just want the number of things. I just want stuff. I don't want groups of things because I want to do this. So I can just randomly, and it's random. I can just turn them off and on. Okay, so that's how many things I take out. You want to change that? You don't like that? You plug in the S for seed, and then you can just say, I want to take 74 things out, but like keep rolling the dice. Okay. And again, not structurally sound. That will not work, like in any case. What happened was, in order to begin to turn things off and on, I can't have them in groups. I need them as just a big, long laundry list of bricks that the robots can like take out. Okay. So that's why I had to put them into a geometry component. And then when I made my translation, I had to graft it so I could get each row, right? And then I took each of those rows, 25 bricks, and then I flattened them. We'll talk about this more. But anyway, I just want to show you, like, so there's culling, and there's also like random reduce is like another nice kind of way to get some different things. Different cull things. You can cull like every third, fourth, that's what nth is. You can cull numbers. You can cull an index, so I can say like take number 3 out. Or I can give it a list and say 316, 911. I can surgically like remove stuff. So all these things are in the cull index here. And I'll show you what that looks like, why that's important. Okay, so going back to this. So there's these horizontal frames. You can also do vertical frames. Let's see, sometimes it doesn't show up. So if I go under curves, yeah, division, oh, perpendicular frames. This is the guy again. The opposite of horizontal you would think might be vertical, but it's perpendicular. So perpendicular frames. So we plug in the curve and we plug it in for this, and you can see I can get the perpendicular frame. And that's it. That's interesting. Like if you have some geometry that you want to rotate or something. Can I do a torus? I can do a torus. Oh man, that's a giant torus. Okay. Well, okay, fine. Where do these all show up? I just want a donut. Okay, it's not going to do that. Let's make a. Well, if I can make my cylinder buddy again. You can see what that looks like. So yeah, woo, now it's Sonic the Hedgehog or something. So you get these things that way. Okay. And that can be useful for all kinds of reasons. Another kind of hacky thing you can do with that actually is you can take something and I can use it to do a cross section of something, and then you can loft them together, and that gets you something and say, well, that's just a pipe. Well, yeah, but if you actually change the scale, you know, of those things, using your graph mapper or like whatever, you can get like a really dynamic, you know, kind of form. Okay. But that's where loft comes in. Okay, so anyway, that's distribution on a curve. Okay, that's the big idea of that. Let me take a look at the slides again. I'll show you. So now we'll like bring it back. Okay, so I showed you an example of you can imagine, you know, taking these curves, and now these are very vertical. They're the same logic of a shingle is like a brick. It's just like a tall, narrow like brick. Okay. The logic of these like slats, you know, again, you could have two curves that talk to each other. You could take a rectangle and extrude it, and a thin rectangle is a slat. You want structure, you can move that line behind it and extrude like some kind of section along it, and that would also give you, you know, something. I think that's also really useful. So those kinds of things, you know, are pretty easy to duplicate. I'll skip around here. Yeah, so I'm gonna talk about this one. So next I want to talk about surfaces and how we get things on the surface. So you can distribute things along a curve. And a curve can move like three-dimensionally and like so forth. But a lot of times we want to panelize a surface, or we want to like subdivide into something. We want to do like a facade or like whatever. Like, so it's very useful to be able to look at, this is a gallery, and so it has these like holes in it, right? And so I want to talk about that too. Okay, so two more things today. So let's start a new script. So yeah, okay. So one of the most important patterns that you're going to come across is subdivide surface. And I want to teach that to you, and then we're going to see a different context here. So I'm just going to make a surface, because a lot of times you'll have a surface, like you're going to make it, and you don't really care if it's parametric. You just want to make like some cool thing out of it. And so I'm just going to set a surface. Okay. And remember, we can make a surface out of lofts or whatever. But I'm going to make a surface, and this is a pattern I want you to pay attention to. Okay, so hold up. So domain, divide domain squared. It's this one. Okay. Oops. Yeah, you can't see me. Ah, nobody told me. Everybody's paying attention. All right, I'm back. So let's undo all this and stop. Nobody told me. Okay, so we're gonna make a surface, and I usually just do, if I'm doing a demo, I'll do like just a point to point. Okay, surface, and I'm gonna do a surface container. Later on, we're gonna make a surface, but right now I'm just gonna demo this. So, set a surface. Okay, and now there's a pattern I want you to pay attention to. So we're gonna do divide domain squared. Remember, we had construct domain. Now we have divide domain. So how do we take something and actually break it down into things, okay? And the divide domain squared is because it's actually acting in 2 dimensions. Remember, surfaces are 2-dimensional. Like, they're just like a little piece of paper, okay? And no matter what shape that like it's bent into, in the computer, it actually is just flat. It's just square. Even our like sphere, you know, I can't even do that, is just a square, like as far as the computer is concerned. And that'll matter in a minute. Okay. So divide domain squared. Nothing happened. And then we're going to take an isotrim. An isotrim extracts a subset of a surface based on a domain. And what does it look like? You can divide it. You can divide any surface into like units, grids, whatever. So what is that like? You know, what do you do with that? So like I don't know if this is going to work right now. Yeah. I've been doing this all day and not doing this right. Okay, so you can do all kinds of things with it, like giving it a grain. Okay, so you can have it be more vertical and horizontal. You can also use math, right? You can take this 1 times 2 is v. Remember the textures, you know, the horrible texture mapping stuff we did in the first lab? UVW, right, is the space of these like surfaces. We think of it as X, Y, Z, right? Like in our world, right? But in the surface, the addresses are UVW. So U is roughly X, V is Y, and UV, and W is Z. Rarely use W. And let's give this an actual kind of example here, or whatever. So I'm just going to make a better. So that pattern can like subdivide a surface, and that's not even a great example, because like that's not even a surface right now that's actually very hard for us to work with. But what if we did something that had some like double curvature, right? And then it becomes like a lot more interesting and expensive to build, right? So if I take these 2 curves together and I loft them, you know, I get some ridiculous, you know, kind of surface or whatever, and then I can reference that. Okay, now we're cooking, right? So now I've got this surface subdivided, and that becomes really interesting, right? But it's still just U and V. Okay. And just to show you something. So there's all kinds of things too, like you can evaluate surface, evaluate curve. So evaluation is just like a way to say like, get me some information about that, right? And so there's actually this tool that's like evaluate surface. And you plug in, you can plug in a surface and it will give you like information like if I'm at a point on the surface, like what's the coordinate, what's the frame, et cetera, et cetera, et cetera. So this is a way of translating your like spatial things into some kind of like information you can use. And this becomes really, really important in just a bit here. Let me hide this thing. There we go. But there's all kinds of things you can do with it. Like you can get the edges of it. You can get points on the surface. You can find, we sort of talked about finding the area. You can find the volume of a surface. So these are all different ways that you can get things out of the surface. What I'm trying to do though is, let me see here if I can do. Oh yeah, okay. So point. Let's see. Yeah, okay. So now we can construct points, right? And that's XYZ. We plug in XYZ. Well, there's actually a variation of this. It says that's point UVW, right? So we can take a surface. Well, actually, is it going to be? Yeah, it's not going to do that. Okay, never mind. We can take a surface and we can plug in those coordinates. And we can find like a location on that surface. That's not going to work for me right now for a reason. Anyway, so we've got a different way. So if we try to orient things to this, it's going to be a little bit different because it's not flat. It's acting in different ways. And some of these surfaces are turned towards us and some of them are turned away from us, right? And so it's something you have to be mindful of. Like when you're trying to align something to it, right? That makes a difference. So we got a surface. The other thing I want to look at is this deconstruct Brep. So Brep is just boundary representation. It's something that Rhino uses to describe a form. You're representing a boundary. It's like this is all contained within a space. If you plug in the B, it's a giant thing on fire. It's explode. Now you can get all the faces, all the edges, which is the lines that make it up, and all the vertices of it. Okay. And that's a lot of information that's coming out of that surface, right? Or any object that can be a surface. So this is really strong because like I can take something and I can put spheres at every single point. That's gonna hurt. This is where your computer starts to crash. I hope yeah. So sometimes you just have to let it run. Did I crash Grasshopper? I might have. All right. Sometimes that happens. You have to be careful with that. I asked for too many things, I think. Wow. Yeah, I might have. Sometimes you lose the window, but sometimes if you do things that it's asking for too many services or too many like connections or whatever, you can end up crashing it. And I think that's what happened here. Okay, hang on 1 second. Let me see what let me see if I can get it back, I guess. Oh, that's really funny. It happens. Okay. Should have done that. Spheres have a lot of geometry. And so that's why you have to be very careful about that. Oh, there we go. Okay, I got it back. If your computer hangs like that, you either have to wait or you have to you can try to hit the escape key and to stop the thing and it'll stop the script. Otherwise, you can open up Task Manager and I'll maybe show you a link about that, how to fix that, but that happens a lot. So anyway, I have all these points and I used all the points to make surfaces. Oh, sorry, to make spheres. Easy. I made these little nodes way out of scale, but that's, they're all there. So that's interesting, right? I can also pipe all the edges. I can do all kinds of things with it. One of the yeah, so that's something that's possible. I'm actually gonna turn this down. So here's the thing too, it's very easy. So like 10 times 20 is 200. That's a lot of things to like deal with. So maybe I can make this a little bit easier to manage for everybody and just make it maybe 25 things. Okay. Anyway, so things you can do with this, you can get the area of the frames, and that gives you the center point of each one of these things. And that's an easy way, again, to distribute some geometry. Like if I wanted to put columns under it or something like that, I could do an SDL, and I could make some big, I can, so that just projects down from each of those points. That's it. And in fact, you can see, and it moves with it. So they're not smart. They don't go all the way to the ground, but that's it. Okay. But what if I wanted them to actually like move, that I actually wanted them to move with it or something like that, right? So that might be something that I want. Remember, like, it's like the example of the bricks before. It's really easy to just put them on frames and they're flat, but what if I wanted them to flow? Well, what if I wanted it to flow in the way that we saw the other example, right? How would I, how would I do that? And so like one thing that so the way to do that is like to go back to that evaluate surface, and I can take all those like frames or faces, or I guess, and I'm gonna flatten them. They don't need to be grouped like that. Everything starts off in like a data structure. I don't really want that. And then the centers are gonna be flattened. And so it basically asks me for this UV coordinate. And if I put the UV coordinate, oh wait, see, that doesn't work either. Okay, we need to find the closest point on surface. I forgot. Yeah, because so these are not UVs. They need to be, so we'll say, okay, look for all the surfaces, look at all the points, and then this gives us the UV coordinates of the oh, and that's not flattened. Shh. Anytime you get too much stuff, that. There we go. Okay. My bad. So these are the UV coordinates. There we go. So now, okay. So these are the XY coordinates in space. They need to be converted to UV. So what this is it says like on this surface, if you look at where this point is, let's convert it to UV point. And the UV points give us the frames at each of those points. And the frames are where we can put geometry. And you can see that they're aligned. I hope you can kind of see that. They need to be a little bigger. I thought there was sometimes you can change the plane size. I'm not going to be able to do it right now. Anyway, there's a setting for that. They're really tiny right now. But anyway, just to show you what I did before, we'll do the opposite. We'll do like a porcupine. So we'll take each of the frames as the locations of these. And the way that these things are actually directed is not going to be Z. It's going to be in the plane, which is the normal. And the normal is the thing. Anything that's a plane, if you have a line that's perpendicular to it, is the normal. And so that is the normal. And if we stick these things out here, no, that's the opposite. But you get like I'll just do the opposite. Yeah, you get like a porcupine. And so now these are flowing along that surface. They're local. Okay. This is the difference between just taking the point and just going up and down, and having the local like space that's inside of it, right? Because again, remember that these are a special mathematical like space, right? So instead of it being X, Y, Z, or actually instead of Z being up, it's N. That's the normal. Okay. Instead of it being like X, Y here, it's U and V. Okay. And that's what allows us to flow things along some kind of a surface, or like some kind of a space. Okay. And so like what that allows you to do with different things is to say, for example, like, and this won't work like exactly, but let's just humor me now, because I got to do this quickly. I can make a circle at each of the frames, and it will see how big these are probably too big. Oh, those are pretty good size. And you'd want the circle to flow along that surface. You know, you don't want that surface. You don't want it to just be, you know, dumb. So we can show you the differences. Yeah. Oh, that's broken. But let's see here. Frames. Oh, centered. Yeah. So it's that, right? Versus this, which is what you want. Now, again, I made this as a surface, but imagine this is your facade or something. Imagine it's the outside of a building, right? You could put something on there. Okay, I'm gonna try something. Oh, okay, so here's the thing. They're not on the surface, okay? They're drawn on a plane, but remember the surface is doing like this or whatever, right? If you zoomed in, they're not quite, yeah, you can kind of see it. You can see that, like, see that right there? They're not on the surface. So if that's your problem, what you kind of think is like, oh, I'm going to intersect it with the surface. Oh boy, if you do that with like 500 of these things, we're going to be waiting here a long time. It's probably going to crash. You always want to try to work with something at a primitive, you know, level, right? And the most primitive level is to try to loft it or something. Take the outside curve and the inside curve and put them together. You never want to try to boolean it or trim it if you can avoid it. So how do we get these things cut? How do I get that cool thing that I showed you before, right? So I'm going to show you what it should work. So you can project something to a surface. Okay, so the curves get projected, you know, onto the surfaces. So I'm going to take the surface container and pipe in these. The faces are basically surfaces. They are. And we'll flatten them so that we just have 25 surfaces. And so it's take a curve, take a B-rep, which is a surface. Maybe let's make it hard. And you should get the projected curve. So curve. Boom. Now it doesn't look like anything happened, but I assure you, like it did. Let's go ahead and hide these. So now these should be on the surface. You should not see any weirdness with them. Okay. No, actually, I'm gonna lie. I'm gonna try this. We'll see if it kills my computer because I'm running out of time. So we are gonna trim these. So there are trims in Grasshopper, but they're parametric, and I'd be very careful. I would usually disable them because if the trim is running constantly in the background, it's gonna crash your script like over and over again. You only want to run a trim when you're like done. And we're gonna run the trim on the original surface. We're gonna go all the way back to the surface that we had. I'm just making a copy of it, I guess. And then we're gonna trim it with these curves. Everybody cross your fingers or something, because yeah, this is probably a bad idea. And these are found under the trims. Oh, sorry, not trims. Intersect. And so what we can do is we can say, a lot of times, what I will actually do, I'm not going to do trim. I'm going to do a split B-rep. Okay. So we're going to split this. So we're going to take the B-rep and we're going to split it with these curves. Data conversion failed. Oh, I did it wrong. Let's see, curves, cutting shape. That's a curve. That's a B-rep to split. Okay, maybe I have to do this another way. Crumbs. Sometimes it doesn't like that. I just need to do, nope. Cut holes into a shape. Oh, that's solids though. Oh. Why don't you like it? From curve to B-rep. That's not a curve. Right? It's a surface. Okay. I'm going to do this the other way then. Okay, the way I don't want to do it. So I'm going to take all these, I'm going to take all these surfaces. Sometimes you have to try things different ways. So here's 25 B-reps, and you don't want to do that either. Okay. Oh, that's split with another. Oh no, yeah, so that won't work. I need a physical. Let's see here. B-rep curve. Solve intersection events. Surface split. Oh, that's what I want. Okay. That's what I just did was different. Okay, so surface split is what I want. I'm going to take a surface, take a curve, and okay, and so what you get is a list. Oh, that's fragments. Oh, shoot. Okay. Surface split. That's not what I want. Oh, maybe. Let's see. Let's see. List item. It might be. Oh yeah. Okay. Jeez. Okay. Just looked weird. Ta-da. Okay. When you do this, you get a fragment for every single object. The first object in the list is your surface. So you do a list item. And that gives you the split. That gives you this thing. And that's how you that's one way to get a hole in a surface. If you want to make it a solid, you can just like you can offset the surface or different things. But anyway, all this is to say we distributed some geometry over a surface. And then we used it. We had to be mindful of the different things about the way surfaces work, right? So surfaces operate in UV space. We divide them. We can use this tool, this pattern, the Isotrim, to split a surface. We can use Explode Brep to get the parts of a surface. Okay. And to get things that operate on a surface, we have to like evaluate, which means that we have to like find the UV coordinate based on the like center point, based on the center point. Because if you don't, otherwise everything's just going to be flat. That gives us the frames, which are the kind of some combination of the perpendicular and horizontal frame, that they flow, and the normals, which tells us which way is up or down from that surface. Which way is away or which way is close to that surface. And then we can put geometry on it, but if we want to like have something that's on the surface, we have to like project it. And projecting is like taking like a big cookie cutter and like smooshing it into the surface. Okay. Then we can trim it. And that's a cleaner operation than just booleaning it. Okay. And that'll work for, I did circles, that'll work for any shape. Okay, I can put any shape I want. Okay, let's take this home. I know it's like a lot of stuff. So just to point out, like to go back to something that we did, I can take these things and I can create like a pattern on this surface. I'm gonna kill this because it's gonna hurt my program to run that. I'm gonna make more stuff because it's more fun that way. And I'm going to go ahead and I can, so what if I wanted to make this into some kind of cool brick or thing, I can extrude these. So I can take each of these things and I can take each of these surfaces and I can, so a vector is basically, when you do a Z or an X or Y, right, you're taking the vector direction, you're multiplying it by this factor. It says multiplication. Okay. You can take an arbitrary vector, in this case, the normal, which is a vector. And if you multiply it, you can get a vector coming out of that shape. We're going to wrap this up here. Okay, so, yep. And so that's one way. So now these are all extruded. You can see. Actually, it's always like the opposite. Let's just do, yeah. So let's make this negative. Let's do negative 20. I don't know why it's doing that. Probably because of the way I drew it, but if it's going the wrong way, just do it in a negative direction. So now we've got these things. You can see that though, like I can make this thing, I can extrude it like based on that, and I've got all these things. Right? Check this out. Let's do Cull Pattern again. And I can go through, and the easy thing, right, is just to do, true, false, or false, true. You can do any pattern you want. You can get crazy with it. But I've got something that's got some geometry, to it. Let's see here. So I have like a little supplement I'll put up, and I'll do like a review and kind of break some of these patterns down again. But just wanted to show you some stuff. So this this surface is periodic surface, right, with these circles in it. I mean, I think that's almost like a direct copy of what we did, you know. And then am I missing? Oh no, okay. Yeah, I don't know why they did that. Okay, so like you can imagine taking some of the things that we had, taking a surface and like distributing something, changing the scale of it, and then trimming it, right, to get some of these effects. This is an example, this idea of like, you can take a facade, you can break down the surface into smaller units, extrude them from their normals, and then cull them to get like rhythms of different things, right? So these are like really straightforward. And what's nice about the pattern, you can say, Nick, like, I don't care, this is like due south. All I do is extrude it in the Z or extrude it in the X or the Y. Normals will work no matter what direction something is like facing. It doesn't matter, right? It's much more like flexible. Okay. And they did kind of a crummy job with this. Like, look at the proportions. They just like cut this thing. They didn't even align it with the pattern. They did a better job over here. But you can, you guys are architects. You can figure it out. Anyway, okay. So the assignment, like I said, we give you a volume and it allow you to kind of break it down. So like if you wanted to explore putting a facade on it or putting like a canopy on top of it or taking, some of the edges of it and doing some different things, I'm going to give you guys a kind of a workflow for that to say like, how do I break something down? Like, what are the things I want to distribute? What are the patterns I want to like, that I want to apply, to that thing? Cull patterns kind of give you a rhythm that's really useful. I'm going to talk about this one too. I'm going to demonstrate this. So I ran out of time and I know we're almost done. We are done. What I wanted to show you was this. This is like Heatherwick, Thomas Heatherwick, and this is the like British pavilion, and it's a seed pavilion. They're these big glass tubes that have seeds in them, and they like penetrate the volume all the way from the inside to the outside. And it's this giant like hedgehog thing, right? And before this class, maybe you'd say, God, how would I even do that? I would say now you have some idea about how to do that, right? That you can take this form, right? And you could distribute these things all on the surface, right? All these things are radiating like out from a surface, right? I'm going to go a step further and go back to the first thing I was talking about with the NURBS, right? With the NURBS things. And I'm going to show you how you can make them like fruit so that they actually have like gravity as well. So that's my bonus. That's my bonus track on this mixtape or whatever, fellow kids. Okay, so like all this stuff kind of comes around. Where do you get ideas for these things? I mean, you look at architecture, you look at different things, and you like start to copy things, but then you start to come up with your own ideas for things, right? And you play with them, right? So what would happen if you did a different shape? What would happen if you did a different distributed like item? What would happen if the proportions of those things changed? What would happen if they got longer as they came up out of the top, right? Those are all the different kinds of things that you can play with, right? And we did all the stuff last week with variation. There's no reason why this has to be uniform, right? There's no reason why these have to be the same length. There's no reason why they have to be these things, right? And you could start with Heatherwick and you could end up with something like totally different. And you could start with Calatrava and you can start with like this thing or whatever. There's lots of different things to play with, right? As you start to get going, okay? And you're just seeing it. You're just getting exposed to it. You're looking at it. It takes practice. It takes some mindfulness, and it's okay. If it's really common to feel lost or not to be able to pick up all the little pieces of it, but everybody started where you are, and that's what we're here for. Okay, so just let that percolate for the rest of the day as you kind of think about it. I got some stuff to put up on Lab 6, and I'll publish that last video as well. Of course, this video will be up too, but hopefully this is interesting and useful. And yeah, okay, you guys have a good weekend. Oh my gosh, it's the weekend. That's crazy. I have I have my only Lego that is a St. Patrick's Day, which is this one leprechaun. Yeah, that's it. That's all I have. So, but then Easter, I have so much stuff. All right, hope you guys are well. Hope you're still here. I will see you later. Thanks, Ellie. Thanks, Ben. You guys be well. Thanks, Emily. Go Iowa State women's lacrosse. Yeah. Good luck. Thank you, everybody. Have fun with it. Woo! Cyclones. Everybody cheer on Emily and her squad. Everybody stay safe. I'll see you guys.